All right. Right. Good morning to you, grade 7 learners, mathematics. Welcome to the maths class. We are now about to start with our lesson. And what is very key here is that we are going to look at the surface area of prisms. And of course, we have spoken at length about the 3D objects, and we have defined a prism as a 3D object that has two parallel and identical faces, which are known as polygons. So basically, we are talking about polygons, which consists of two identical parallel faces, which are connected by the lines, most of which become the rectangles, as you have seen with some of the examples that we have spoken about. And of course, I'm going to zoom directly now without any waste of time, just to indicate that basically the prisms have a pair of parallel lines which are congruent faces. Remember that when we talk about congruent polygons, those are polygons which have the same shape and the same size. So the same size and shape. So the size has to be the same, but equally the shape. We have also spoken about the cuboid, which is another name of a rectangular prism. So every time when you see the word cuboid, you must know that it stands for the rectangular prism in this case. A cube is basically another type of a cuboid, meaning that it's also a rectangular prism, except that in a cube, all the edges are equal. Remember that a cube is derived from a square. So in fact, a cube consists of about 6 squares which are joined together. If you have your net of 6 squares, you can be able to practically join them together to complete a cube. And that will be a 3D object. And once you have done that, you realize that this is a type of a cuboid, alternatively called a prism, rectangular prism. But in this case, all the edges are equal because the edges, remember, emanate from the length as well of the squares. So therefore, a cube is also a rectangular prism. But at the same time, I want to also bring to your attention the triangular prism. And this is a prism in which two parallel faces are triangles. So basically, if you take two triangles, which are joined together by some rectangles, these particular triangles form the faces of a prism, which is known as a triangular prism. So basically, a triangular prism consists of two faces which are parallel, and those faces must be triangles as such. We have also spoken broadly about the 3D objects, and we've characterized our 3D object as having the length, the breadth, as well as the height. So if you look at this prism here, it consists of the length, which is 15 centimeters. It also has the breadth of 4 centimeters, and equally it has got the length. In fact, not the length, we've already spoken about the length, but the height of 3 centimeters. So just to recap, this prism in our midst consists of the length, the breadth, as well as the height. And the length of the prism, as you can see, is 15 centimeters. That is what the length is. And the breadth is 4 centimeters. And what about the height? The height in this case is 3 centimeters. You can see the height of the prism. Now, what becomes key here is to also check what type of a prism is this. That is what we need to do. What type of a prism is here in our midst? That's the first thing. What type of a prism is this in our midst? Remember that our group chat is very active. Alternatively, you can also just indicate by raising a hand. I hope that you can still hear me. Hope that you can, yes. You can just indicate by raising a hand as well. I see Amo says it is a triangular. Amo, your answer is not complete. Can you finish the word triangular? Triangular what? We have the triangular prism. We also have a triangular pyramid. Is this a triangular pyramid, Amo, or is it a triangular prism? Right, Amo says it is a triangular prism, and your thoughts are supported by Zetu, yes, Zetu Dodana, together with Fizana. Thank you very much indeed, Fizana. This is a triangular prism, and basically we know that it is a prism because there are two triangles, two parallel triangles which are joined together by the parallelograms, in this case, the rectangles. And of course, now that we have studied this, in fact, I want us to study it because at some point I would want us to answer the questions that follow, that emanate from the rectangular prism itself. Okay, thank you, Kanye. I've noted your comment. Thank you very much indeed. Let me not forget what you have just told me now that your name is Kanye. Thank you very much indeed. If I make a mistake, it will be because I just see that your name is written as Zetu, but your point is noted. Thank you very much indeed. Thank you, Kanye. Right, we are now going to proceed. I hope that you are studying this particular prism just to be able to test whether the prism will be, whether you'll be able to answer some of the questions that follow. For instance, given the above prism, I want to test whether this is a regular prism. Perhaps you need to just ask the question, is this a regular prism or is it an irregular prism? You have probably been exposed to prisms before, and I want you to tell me, is this a regular prism or is it an irregular prism? Remember that a regular prism will have those bases which are congruent, whereas an irregular prism will have bases that are not congruent. For instance, a regular cube or a regular rectangular prism will have the same faces, that are joined together by rectangles just to complete our prism. So The key question here is whether the prism that we have here, the rectangular prism that we have, whether it is a regular or irregular. We have regular and irregular. So to answer this, this is a regular prism. The reason being it has two parallel bases. We've spoken about the triangles, you've seen them. I've shown you the triangles. And we know that once you have a prism that has got two parallel polygons, then we say that that type of a prism is regular. So the answer to that is that this is a regular prism. Now, can we name the basis of the prism? The basis of the prism, can we name those? Right. As we allow many learners to enter the class, can we name the number of bases that are there? In fact, the two bases that are there, can you give us what are the names of those bases there? Right, you should be able to see that, as I've said, there are two triangles. There are two triangles that form your bases. And of course, those are regular triangles. And basically what we need to do as well here is to also check the number of faces that are there in the triangular prism. So I'm just going to take you back to the picture just so that you can be able to see the number of faces that are there. In fact, how many faces are there in this particular prism. So I can see that one of the learners has already answered. In this case, it is Kanye. Kanye says there are two triangular bases. Great. So you have answered the one before. I agree with you, Kanye. There are two triangular bases. Great. That's the correct answer. So those two bases are joined together by rectangles to form a 3D object, which is known as a triangular prism, as you have said earlier on. Now, Kanye has given us a clue now. We now know that we have two triangular bases. Thank you very much indeed, Kanye. But now the question is, how many faces do we have? How many faces are there in the triangular prism? How many faces do we have? We need to have the capacity to count the number of faces in this particular 3D object, which, by the way, you are unable to hold since it's drawn now. It's more like it's a 2D shape, or in fact, it's a 3D shape now that you can't hold it. An object normally can be held. So if it's on paper, it becomes a shape. Then when you can hold it, then it becomes an object. I think the distinction is clear there. Right. Kanye, together with, I can't read the name, I think it's X. I can see X equals to 12 there. I just don't know your name. Kanye says that it will have 5 faces. It will have about 5 faces. Yes, I fully agree with Kanye. There are definitely 5 faces in this regard. And there's not only Kanye, but there's also another learner there with the name X on the name of your gadget. You are saying that there are 5 faces. Now, before we can even think of calculating the area, I'm not going to go there now. I just want us to check what are the names of those faces that we're talking about. give me the names of the faces that I'm talking about in this regular prism, also known as a triangular prism. What are the names of the faces of those that are found in this prism? Once more, remember that you said to me there are 5. Initially, we spoke about 2 bases, and I hope that you can now be able to relate and tell me what are the names of those faces. If you can just give me the names, I'll be very happy. As we welcome Jabulo to the class, what are the names of those faces? So you need to have the faces, but you must also be able to name them, unless if you are using Google there. I know that some of you may Google the number and you may be told that it is 5, because if you Google the triangular prism and check there, you'll see the faces, the edges, and so on. I know you can get those answers easily. Right, Kanye says that the top and bottom are triangles, great. And the 3 rectangular ones are called lateral faces. Exactly. Yes, the top one and the bottom one, meaning that the 2 faces in this case are triangles, and the 3 ones which are rectangular in shape are known as lateral faces. So lateral faces are the remaining faces in this particular activity. And without any doubt, I just want us to remember now, you will recall that at some point you were able to do, to calculate the different areas as well as the perimeter. We have done area and perimeter of 2D shapes. This we have done. We have done this in term 2, the area and the perimeter of the 2D shapes, where you were able to calculate the perimeter of a square, the perimeter of a triangle, as well as perimeter of rectangles and so on. But equally, you were taught how to calculate the area of a 2D shape. So in this case, all that I need you to do now is to calculate the areas of the bases in this case. So meaning that you need to calculate the areas of the triangles. So remember that we are given we are given this particular rectangular, the rectangular, not rectangular, but triangular. It's a triangle, so it's a triangular prism. So I want you to calculate the area of the 2 triangles. Basically, that is what I need to do. So please take out a pen and a paper. We have the triangular prism in our midst. Use all the given information to calculate the area of the 2 faces. So if I may give you a hint, you can just do the area of 1 triangle and thereafter multiply your answer by 2, since we have 2 triangles which are equal. So if you get the area of 1 triangle, then you can use that to find the area of the other triangle. So basically the 2 areas will have the same, the 2 triangles will have the same area, because remember, they are congruent. So they have got the same size and same shape. Same shape, same size. All right. Size and shape, they're equal. So I hope that you understood the question. You can see there we have the base, which is 4 centimeters. And of course, we're also given the height. So remember, unless if you have forgotten the area or the formula, how to calculate the area of a triangle, I can put it for you in the, just in the group chat, just to ensure that you have the capacity to to use that particular formula just to solve the problem. I think that maybe that is what I need to do. Maybe that's what we need to do just to ensure. Let me put it for you, for everyone, for the benefit of everyone, just to have the formula once again. The formula to calculate the area. Remember that we have always said that the formula for calculating the area of a triangle is given by A is equal to half of the base multiplied by the height, the perpendicular height in this case. Can I give you 30 seconds just to calculate, and then if you are ready, please tell me. 30 seconds. Right, I hope that you have now managed to calculate. Right, so basically the area of this triangle will be, you have got the base. So in the absence of an answer there, I'm just going to reflect that we have the base, which is given at the bottom there, the base of the triangle. Remember, we are now our focus is now on the triangle. So our focus is right now on the triangle where we have the base, but we also have the height. And of course, the height of the triangle there is given. And the triangle height there is 3 centimeters. So basically you can use this information to complete your exercise or your activity. Right, in the absence of an answer, I'm just going to demonstrate that basically all that you need is to utilize your formula. Remember that the formula to calculate the area is given by A is equal to half of the base multiplied by the perpendicular height. And then we proceed to show that you can be able to substitute correctly. That is what is important. And then this is half of, remember that when you multiply the base and the height, so you're basically multiplying 3 by 4. All right. So 3 times 4 gives you 12, and half of 12 is 6. So you'll have 3 multiplied by 4, which is 12. And of course, half of 12 will be equal to 6, which means that your area will be equal to 6 square centimeters. So basically that will be the area of one triangle. Remember that in a triangular prism, there are 2 triangles. In a triangular prism, there are 2 triangles. And then of course, you can be able to utilize those just to find a way to exercise this particular activity. Right, now the area 6 centimeters there, and then remember that there are two triangles. There are two triangles, which means that you just have to multiply now the area by 2. So if you multiply that area by 2, so you'll have 6 multiplied by 2, which is 12. So basically, the area for the entire two faces will be 12 square centimeters. So basically, that is what we have, 12 square centimeters. So remember, this is just easy. I'm just going to remind you that you need not be scared of the 3D objects or the 3D shapes. So what is important is that we have to ensure that we thoroughly apply the same lessons that we, or the same experience that we have, the lessons that we received previously in relation to 2Ds. So basically a 3D is just a combination of 2Ds, if you can look at that. For instance, your triangle, once you start calculating the area of this triangle, it's more like you are working on a 2D. It's the same as working on a 2D. That's what I wanted to say in relation to this particular activity. All right. Now, I'm just going to give you an opportunity now. I think what I want us to do without any waste of time, I want us to look at something called the surface area. This we have done before. We have done the surface area before, and then the surface area is simply the total. It's the total of the areas that are there, that are found in this activity. So the surface area is the total area of all the faces that are found in this instance. So that is what I wanted us to do. But before we get there, I just want to wrap up some of the words. Remember that we have got the pentagon, the hexagon, and so on. You know, these words that come just before the pentagon, the word penta, for instance, it's a polygon which has got 5 different lines there. So it's a 5-sided figure. When we talk about a pentagon, the word penta means 5, and tetra means 4. Hexa means 6. And you can see that we also have hepta, which means 7. Then octa, I'm sure you have heard about the octagon as well. It means it's an 8-sided polygon. And of course, we also have nona, which stands for about 9. And then deca, it's 10 there. So you've got 10 for deca. And then, of course, those are the Greek words which are found in mathematics, which we can use to. So the next time when we ask you a question about any of this, please remember to ensure that you know what they stand for. Now, imagine that we have got this triangular-based prism that we have just spoken about. We just spoke about the triangular prism, which consists of 2 bases, which are triangles. And of course, we want to ask a question now this morning, that if the base of the pyramid gets more and more sides, what will happen to the number of faces? So imagine now, I was just showing you the different meanings. Let's say you have this triangular prism, and now the base gets more and more sides. Let's increase the base by one side. So obviously when you increase the base of the pyramid, the base of the pyramid gets more sides. What will happen to the number of faces? Will they increase or decrease? Excuse me, that's the question that I have. Yes. Will the faces increase or decrease? All right. Fizana says two are triangles, the other one is rectangles. Okay, you are answering the previous one. So tetra means 10. Okay, great. It gets less with less sides. Yes, of course. I agree with you, Fizana, you are correct. It gets less with less sides. So if you decrease the base or the sides of the base, then even the number of faces will decrease. Take, for instance, the triangular-based pyramid. Remember that a pyramid has got only one edge at the top. And of course, where the lines meet or where all the triangles meet, all the triangles will meet at one point, which is the edge. And then, of course, we also want to analyze the manner in which this will affect the faces if you increase sides. So if you increase any sides, if it is a triangular-based pyramid, so if you increase the sides on the base, meaning that if you move from a triangle to a square, so you can see that you now have 4 sides. You've moved from 3 sides to 4 sides. So basically, even the number of faces will increase. I'm sure you'll agree with me on that you will have now 4 triangles to form your pyramid. So that is what we mean. And then, of course, we want to calculate now the surface area of the entire prism. Is there anyone who is willing to just take a pen and paper and just to calculate the entire surface area? Can we proceed to calculate the surface area of the entire prism? Calculate the surface area of the entire prism. Remember that when you calculate the prisms or the entire prisms, the surface area of the entire prism, what is important is to look at the faces, the number of faces. We have already spoken about the triangular prism and we said it has got 5 faces. So can you calculate the area of each and every face? Yes, Huapele, we're calculating yes, we are calculating the faces, the area of the faces there. All right, so in the prism. So we've got about 3 of those. Can we now calculate the area? So if you calculate the area of each and every face, and then you actually ensure that you are able to equally, just to demonstrate the capacity of your ability to ensure that you get the area correct. I think that is what we need. That's the most important thing that we need. That is what we need at this stage. Can we do that? And then let's carry on to to finish our task. Just the total surface area. That is what we need at this stage. Right, I see that Lehumo says the penta prism face 7 edges, 15 vertices there. Right, I thank you for that. Yes, the pentagonal prism will have 7 edges. It will have 15 vertices and 10 vertices, sorry, and then 15 edges, as well as 7 faces. I fully agree with you. That will be your pentagonal prism. I fully agree with you there. Lehumo, I see you are responding to Huapele's question there. Bipelo, thank you very much indeed. Tetra has got 4 and Deca 10, yes. I think you were answering the question that was raised earlier on by Fizana. You are right, Bipelo. The Deca means stands for 10 and Tetra stands for 4, just as I've put it in the table that we've just been working with. Now, can we finalize our calculations in this case? Let's finalize calculations. Right, we are going to finalize it as follows. When we calculate the surface area, remember that all that we need to do is to look at all the faces. And I'm going to give you some of the examples once we are done. I'm sure this will help you to calculate the surface area of this particular prism. Remember that any solid, for instance, consists of a vertex or vertices if there's more than one, then a face or faces if there's more than one. Obviously, there's more than one, and edges as well. So we have defined a cuboid, which looks like a brick. As you can see, the one shown above there, it has 6 rectangular flat faces. Now, if you have to calculate the surface area of this cuboid, it means you must calculate the area of each and every face. Basically, that is what you need. So the same goes for a cube. A cube is just a rectangular solid, also which consists of 6 square faces. And of course, all the edges there are equal in length. And the other thing that you need to do is to look at the measurements. And when you are given measurements, you should be able to utilize those to calculate the surface area. By the way, the formulas for surface areas are given there, but you don't have to really memorize any of those for the simple reason you just have to know that you can just do the area of each and every face. And if you combine all of them, then those will give you the surface area. And a key example is when we want to calculate the surface area of these prisms. Let's concern ourselves now with some of these problems. You can see the first one there, it's a triangular prism, which is followed by a cube. So if you have to calculate the surface area in this case, you have to look at the faces. Let's take B, for instance. It has got how many faces? There are 6. And then there are squares. Remember that the area of a square is side multiplied by side. So you multiply a side by itself. So the manner in which you'll answer this question, as you can see, the side is 8 millimeters. It means you are going to multiply the side by side. The side is 8 millimeters, so you multiply 8 by 8. Remember that 8 times 8 will give you 64. And if you take 64 and multiply it with 6 faces there, it will definitely give you 384 square millimeters. So basically that is what you'll have, 384 square millimeters. So that is what we have in this case when we calculate the surface area. All right. So basically that is what we will have. That is what we will have in this case. And of course, the same goes for the next one there, where remember we also had a cuboid rather. If you look at this cuboid in C, it consists of 3 different measurements there: the length, the breadth, and the height. So you should be able to tell that in this case, our length, the length of our cuboid is 15 centimeters. Yes, you are right, Kanye. It stands for the surface area, yes. Huapele, thank you very much. What we are doing here, we are demonstrating that when you have different units of measurements, you need to convert those. So basically, you must just convert your centimeters to millimeters so that you can work with the same unit of measurement. I hope that makes sense. So you should be able to work with the same unit of measurement and then to calculate. So we have done that, and then we basically you calculate the area of each and every face. There are 6 faces in a cuboid, and then you calculate the area of each of those, and then you should be able to find the surface area. So basically, these are the examples. You can tell that, excuse me, the 15 centimeters, if you convert that to millimeters, you get 150 millimeters. So that is basically what we have done. And then the length now becomes 150. Why? Because you have to work with the same unit of measurement. So you can't work with centimeters and millimeters at the same time. You must convert one so that they are aligned. You need to work with the same units of measurements as I've said. And of course, we close our lesson by just showing you the different descriptions there, that we can have a rectangular prism, also known as a cuboid, as well as a cube. You don't have to memorize, like I said, forget about memorizing the formula. All that you need to know is that every time you have to calculate the surface area, you need to use the areas of all the faces. So if we say to you, calculate the surface area of the cube, then it means you are going to calculate the area of each and every face. But in this case, we just do one. It's enough to do one face, the area of one face, and then you multiply it by 6. And this happens only in a cube. Whereas in a rectangular prism, you can simply calculate the area of each and every face there. So this brings us to the end of this lesson this morning. Once again, our lessons are brought to you by the STEM Digital School in partnership with the Sasol Foundation. Until we meet again tomorrow, in fact, not tomorrow, but Monday, thank you very much indeed. Have a good weekend.
Goodbye, sir. Love you.